brought to you by Gauteng Department of Education in collaboration with Sibona Discovery Center. Okay, good learners, our WhatsApp number is 079-578-2908. You are more than welcome to send your solution or your questions to that particular number. I am repeating it again. Our WhatsApp number 079-578-2908. Welcome to the session, grade 12. And then now our session today is on differential calculus. And then the objective of today's lessons are, after the completion of the lesson, you will be able to understand the concept of limits. Number 2, to determine the average gradient of a curve between 2 points. Number 3, to differentiate using the first principle, whereby we will be looking at the equation f at x equal to k. This k stands for any constant value. It's a constant value. And then secondly, we'll be looking at f at x equal to ax. A representing a constant with an x now. And then the third equation that we'll be looking into in differential calculus using first principle is the equation of f at x equal to ax plus b. Grade 12, as you can see there, we are working with equations with x to the power 1 only for technical mathematics. We are not doing the x squared, the x cubed, the fraction first principle. We are only focusing on the x equal to x to the power 1, which is the linear one. Okay, and then now, without any waste of time, let's start looking into the limits, which is our first topic. And then now the notation for limits, grade 12, we are using the lim of x approaching c, which is presenting any constant value. It can be any number of an f at x equation. That means that will be an f at x given to you in the expression. And then now let's look at the first example here. They say determine the limits. Number 1, we are determining a limit of 5 as x is approaching 5. So grade 12, if you look at this now, in our f at x, we don't have any x there. It's only a constant value, which is 5. In the case where your lim of x is approaching a number, and then in your f at x, we don't have any x, that means the answer will be that constant value, grade 12. Let's take another one. Let's say I'm having now a limit of x approaching 2, and then that is the limit of 3. The lim of 3 with x approaching 2. Since there is no x in my f at x, therefore the answer will be that constant value, which is equal to 3. I hope this is clear, grade 12. And then let's take the second example. We are having the lim of x, and then x is now approaching 2. So the difference between the first and the second one is that now in this case we are having x in our expression. So in the case where you have an x, grade 12, what do? You ensure that there is no factorization or simplification that you must do on your f at x. This one is straight and forward, it's just the lim of x. So we can now apply the 2. Remember, x is approaching 2. It is not actually equal to 2. So we are just going to substitute 2 to make life easier for us in the space where we are having an x, and then this will give us an answer which is equals to 2. That is the second example. Looking at the third example, grade 12, we are having the lim of minus 2x, and then x is approaching minus 3 now. Yes, we do have an x in our f at x. Therefore, where we are having x, the x will now be approaching a minus 3 in this case. So this will give us what? A minus 2. And then for x, we are substituting a minus 3. And be careful, grade 12. As we are substituting, the value of x, we don't write a limb again. Look at that, there is no limb there. There is no limb there, there is no limb there on your answers. So now after substituting a -3, we now end up with an answer of equals to 6. So grade 12, I hope we are still together, continuing with the examples. Okay, let's look at number 4 now. We started with the lower level questions where we are having level 1, and then we will be upgrading as we continue with the examples according to the levels of questions. And then now in number 4, we are having the limit of 3x squared plus 5x, and then this x is now approaching what? A 4. And then if we look at our expression now, there is no factorization important because we don't have any fractions. Therefore, we can go straight and substitute the value of 4 into our f at x. So this gives us what? A 3 into x value 4, and then this is squared plus 5, and then the value of x again, we are substituting with the 4, and then grade 12, no need for partial simplification. Remember, we want to save our work so that our answer becomes perfect. So after substituting, you can just put everything into your Sharp or Casio calculator. It will give you the direct answer, which is equals to the 68. Let's avoid partial simplification, grade 12, because we end up doing mistakes. After substituting, give us the direct answer from that level. All right. So moving on, let's look at example number 5. And then on number 5, we are having the lim of x plus 2, now in a fraction form, divide by x squared plus 5x plus 6. The minute you have a fraction, grade 12, you must be very careful. That means somewhere, somehow, you will be involving your factorization. That means when you are dealing with limits, you must ensure that you are comfortable with what? Factorization. All types of factorization. The common factor, the difference of 2 squares, the difference of 2 cubes, the sum of 2 cubes, and the factorization of a trinomial. Because now they will now be applicable where you are looking at the lim of what? A fraction. And then let's look at number 5. But the involvement of factorization does not involve all the question, okay? Okay, number 5, now we are having x plus 2. Let's look at that now. Our lim is the lim of x approaching 3 now. And then since from the previous questions, we were just substituting the value of x. But in this case, grade 12, you can't. Why? Because you are having a fraction. When you have a fraction, you must be more careful. Check, can you factorize something in your expression? Yes, look at the denominator now. That involves the factorization of what? Of a trinomial. Let's do so, grade 12. So the minute I am busy factorizing, simplifying, I continue with the notation of lim. That means this will still be a lim of what? Of x approaching 3. Why? Because I am still factorizing whatever I am having there. So our denominator here will give us an x plus 3 with the x plus 2. Okay, we have now factorized that trinomial. Immediately after factorization, grade 12, there must be some cancellation of terms that will be involved. As you can see now, you are having x plus 2 on the numerators and x plus 2 on the denominators. And then this now leaves us with what? I am still writing that lim because I have not yet applied the x approaching 3. So what is left for me is 1 on top, and then on the denominator I'm left with x plus 3. Okay, in this case now, grade 12, it is where now you can now do what? Substitute your x approaching 3. So this will basically be equal to, the minute I substitute, I am not writing a lim anymore. Notation is very important, grade 12s. So that will be, for my x, I am substituting a 3 plus 3, which is giving me an answer of 1/6 for that limit. I hope we are still together, grade 12s. Let's move on to number 6. With number 6 again, as you look at the problem, you see again, you are having a fraction. The minute we have a fraction, we check, is there any factorization involved? Yes. If you look at this, we can see that we are having a factorization of what? Difference of 2 cubes. That is why I've indicated to you that your factorization plays a major role in your limits. And then let's start by factorization. As long as I am simplifying, I continue writing my lim of x approaching what? The -2. All right. And then we factorize this difference of 2 cubes. Remember, your factorization will say the cube root of x cubed is x. And then the sign in between is minus. The cube root of 125, remember, is 5 to the power 3. Then it will be 5 here. All right? And then the next bracket is created from the previous one. Remember, by doing what? Square the first term here, it will give you an x squared. And then you multiply the first by the second with the opposite sign now. If it is minus, it will be plus here. And then now x times 5 is a 5x. And then now you square the last term, minus 5 squared will give you a positive 25. And then remember, on the denominator, we still have that x minus 5 as our denominator. Good, grade 12s. Can you see now that cancellation again? There it comes. So we are going to cancel the x minus 5 and the x minus 5 on the denominator. What is left now is what? The lim of x approaching -2 of what is remaining now? The x squared plus 5x plus 25. This was supposed to be over 1, but you know if it is over 1, it's the same. 2 over 1 is the same as 2. 4 over 1 is the same as 4. So the same applies here. The x squared plus 5x plus 21 will remain like that. And then remember now, our x is now approaching what? And -2. We can now apply the x approaching -2. The minute you apply that, we get rid of what? The lim. We just write the final answer now, which is equal to, for x we are substituting -2 squared. Remember, the minute I substitute, I don't write a lim anymore. Grade 12, we said after substitution, you put everything into what? Your calculator. So our final answer will be how much, grade 12? That is 4 for that one, right? And then 4 minus 10 minus 6, all right? Minus 6 plus 25. This is giving us a 19. Remember, you have a calculator, grade 12. It will assist you through your addition and simplification there. No need to stress and scratch your head. You have your calculator in front of you. Okay, moving to the last example, number 7. Look at that one now. This one is a little bit tricky. Yes, we have a fraction, but look at the fraction now. Most of the learners, they will think that it's a factorization of difference of 2 cubes. So most of us, grade 12, what you will be doing, I know that you will be trying to take out a 2 there, so that you are left with the x cubed minus a 4. And then after doing that, you recognize that it doesn't help me anyway, because there is no cancellation after factorizing, and then what is left in the bracket is not even what? A cube, because 4 is not a cube, but it's a square number. Remember, when we have 2 to the power 2, it gives you a 4. So there is no way that we can apply what? The factorization of difference of 2 cubes there. So we are stuck with this problem as it is. If that is the case now, you are having a fraction, but with this fraction you can't factorize. There is no train smash, grade 12, we are still safe. What you can do is that we go straight and do what? And substitute. But be careful. The method that we are going to do here, you can't do it on number 6, you can't do it on number 5. Why? because 5 and 6, you are able to factorize whatever factorization is involved. We only do this number 7 application when you can't factorize anything in that expression. Let's continue then. We have the limit of x approaching 1, and then that is our expression. We are now substituting directly 1 into that. Why? Because you can't factorize and cancel. All right, let's go grade 12. This will be 2. Our x is 1. 2 to the power 3 minus 8. To the denominator we have 3. X is 1 and the minus 2. Your smart calculators, just put everything into your calculator straight to the answer. This is supposed to give us what? A minus 6 grade 12. So basically that is what is expected from you, grade 12s, when we talk the simplification of what? Of limits. I hope everybody is clear now in terms of limits. And then let's take this opportunity now, grade 12, to go through your activity. And then this activity will last us for, let's take 8 minutes on that one, starting from now. There you go, your activity. Okay, grade 12. I hope we are now done with the activity. Remember, we can't spend the whole of the day doing only limits. All right. Be fair to yourself, guys. We are doing the corrections as we do in our classes. So you will be marking yourself, doing corrections where necessary. All right? Just be fair to yourself. Okay. Let's look at the first activity there. We are looking at the limb of 3, where x is approaching 1. Remember, we've indicated that if there is no x, the same constant value that is given on that side is your answer. Done. Please ensure that there is no limb on your answer, no limb on the answer, only equals to 3. And then look at the second solution, grade 12. Okay, this one is having an x, so our x is approaching 3. So basically our answer will be 2 into 3 plus the 3, that is 2 times 3, which is 6 plus 3 equal to 9. Easy? Okay. Moving forward, we are looking at number 3 now. Number 3 is the limit of x squared minus 1. And then you will be attempted to factorize that because you can see that it's a difference of what? 2 squares. But grade 12, remember, we said factorization is only important if you have what? A fraction. In this case, we do not have a fraction. So there's no need of confusing ourselves in terms of factorizing and so forth, because we can end up writing wrong factors which will affect our answers. Or factorize only if we have what? A fraction. Okay, in this case, our x is approaching minus 4. So we will just go straight into our expression and say minus 4 for x squared minus 1. Minus 4 squared is how much, grade 12? 16 minus 1, which is giving us a 15. Notation, very important. No limb. When you substitute your x value, no limb. All right. Moving on to the number 4. I hope you are busy marking yourself and correcting where necessary. In this case now, there comes a problem. We have a fraction. You cannot just decide when you have a fraction. You must check. Can I factorize? Yes, look at that. I'm having a trinomial on the numerators, therefore that's my starting point. I am not substituting yet, I start by factorizing. The minute I'm busy factorizing, simplifying, therefore I continue writing what? My limb. That is the limb of x approaching 0. And then my factorization of a trinomial, factors of 5, when you subtract, give you minus 4. That will be x minus 5 and the x plus 1. And then denominator we have x plus 1. Close bracket for that. Remember, I indicated to you the minute after factorization, there must be some cancellation. X plus 1, x plus 1. So we are left with what? With the limb of x approaching 0. But in bracket we now have what? The x minus 5 remaining. So this x is now approaching 0, which will be equal to 0 minus 5, giving us a what? A minus 5. Grade 12. I hope we are together. And then number 5, look at that fraction again. Check, can I factorize? Yes, I'm having what? The difference of 2 squares there. Remember, 9 is 3 squared. That is why we are saying it's a difference of 2 squares. And then that means our application will be factorization of difference of 2 squares. So since I will be factorizing, I am continuing with the notation of my limb x is approaching minus 2. And then now factorize the numerator. That will be x minus 3 and x plus 3. Difference of 2 squares application. And then denominator, I'm having x plus what? Plus 3. Look at that, grade 12. There comes that cancellation now. We are left with what? The limb of x approaching minus 2 with only x minus 3 now. I can now substitute the x, which is minus 2, because x is approaching minus 2. It's not equal, but is approaching. So it's minus 2 minus 3. Then this gives us a minus 5. Look at that, no limb, because I am substituting my x there. Right, number 6. With number 6 again, we have fractions. So if we have fractions, we check factorization. Is there a need for that? Yes. Look at that. I'm having x to the power 3. Is 27 a cube number? Yes, because it is 3 to the power of 3. Yes, I can now involve what? Factorization of difference of 2 cubes. And then this will give us what? I am factorizing. It will still be a lim of x approaching minus 1. And then my factors now will be x minus 3 into x squared plus multiply the 2 with opposite sign, 3x, square the last term, plus 9. Everything over x minus 3. Okay, cancellation, there you are. And then the next step, we are now writing what is left. X is approaching minus 1, sorry for that. So we are left with x squared plus 3x plus 9. Can we now substitute? Yes. That is the normal limb, right? Normal limb, grade 12, because we are substituting. What is x? X is minus 1. And then this is squared plus 3, x minus 1 plus 9. So that will be positive 1 for that, minus 3, which is minus 2, plus 9, which is what? 7, positive 7, grade 12. So I hope we all got 6 out of 6 for that one. A total grade 12, okay? I think everyone is at total. I'm giving you a hand of applause for that. Therefore, we can now move on to the next topic. The limits are now covered. I know when you have this in your next test, you will get 100% on that one. Okay. Moving on to the next topic. A subtopic, we are looking at the average gradient of a curve. A curve is any function. It can be a hyperbola graph, it can be a cubic function. We are not specifically talking to whatever function only. So we are looking at a gradient of an average gradient of a curve. I know in most cases, educators, when they teach, they say a gradient, it has to do with a straight line and so forth. And learners, they become so confused that the graph has to be a straight line in order to identify a gradient. Okay, we can have a parabola graph, whether facing up or facing down. This part here, the graph is decreasing because look at that, my arm is going down and then it will decrease and become stationary and increase that side going up. So the minute it goes down, that means the gradient here is what? Is negative. Increasing the gradient is positive. So basic grade 12, I'm trying to highlight to you that we can have a gradient in any curve because we are tracking lines. When the line moves down, the gradient is decreasing. Moving up, it is increasing. Therefore, the gradient is positive. If it is stable like this one, remember this is a stationary point here. So we don't have an increasing and a decreasing part at that level because it's where we are having a stationary, which is the turning point of the function. So an average gradient is the gradient of a straight line passing through the 2 points. It is saying straight line. Why? Because if you look at this part here, it is forming a straight line. This part here, it is forming a straight line, all right? Forming a straight line, forming a straight line. Even if I can take a cubic function, I'm having a straight line there. I can identify 2 points there. I can identify 2 points. There's a line there. There's a straight line there. So we can have an average gradient in any curve. And then how do we calculate this? Grade 12, you know, you have a gradient of a straight line. You used to say is n equal to y2 minus y1, the x2 minus x1. That is what we are familiar with. Whereby you are looking at 2 points where the first point will be your x1 and y1, and then the next one will be your x2 and the y2. We are applying the same application. It's just the wording that it's an average gradient and so forth. It's average because it's between 2 points, but the application is exactly the same. As long as you have 2 points, we are just looking for the gradient as a normal way. All right. The average gradient of a curve, the worked out example now. Determine the average gradient of the function f at x is equal to x squared plus x. And then this is between the points what? X equal to 2 and x equals to 5. That means in this case we are given 2 points. But in these points we are only given the x values now. Remember, we have just indicated above that if you need a gradient, you must have 2 points that you'll be referring to calculate your gradient. So in this case, we are having the x values of those points. Mathematicians, you know that in any function, if you are having the x value, you can use the function to find what? The y value by substituting the x value into that particular function. So what is our function in this case? Our function is f at x. Remember, this f at x is representing the value y. Right, let's continue now. We are taking the y function, which is x squared plus x. What is our first x value? X is equal to 2. We substitute the 2 there, and then the 2 here, and this will give us a 4 plus 2, which is 6. Okay, so that means this 2 is now coordinating with the y value equal to 6, which we have just calculated. The second one, we are now substituting in the same function. The value of x is now equal to 5. Let's do so, grade 12. Let's check the y value will be how much. We are substituting a 5 for x, which is 5 squared, and then a 5 for x. So 5 squared is 25, plus a 5, therefore this will give us a 30. Do not take chances, use your calculator to verify your answers. That will be 5 and 30 now for the second point. At the level where you are having 2 coordinates now, you can now look at what? Your average gradient. So you can name the first group as your x1 and y1, and then the second one will be your x2 and your y2. So that is the average gradient. We are using the same formula, that is equal to y2 minus y1 over x2 minus x1. What is y2? 30 from there, and then the y1 is 6, and the x2 is 5, x1 is 2. Grade 12, basically this will give us 30 minus 6, which is 24, the 5 minus 2, which is 3. Okay, which is eventually giving us an answer of 8, all right? So that is all about gradient. Gradient is gradient. Average gradient, gradient is gradient. Is the change in y over there, change in x. Let's look at the second example now. Look at that. The level now is a little bit higher. Determine the value of values of b. There's an unknown now in your question. If the average gradient of, this is our function, and then at x equal to minus 2 and at x equal to b. Let's read the question again. Determine the values of b. I am highlighting all the important information as I'm reading. Determine the value of b if the average gradient of h at x between x equal to minus 2 and x equal to b is equals to what? 1. That means this one is representing what? The gradient of that function. And then we are expected to find the value of b. The minute it says average gradient, your starting point is the same throughout grade 12. You need to identify the 2 points with x and y values. Okay, so let's see now. Okay, let me see. Okay, I'm having my function, yes. Do I have x values? Yes, they say x is minus 2. The other one is x equal to b, which is unknown. But the method to be said is still the same, okay? So I'm having the x for this one is minus 2. I need the y value for that. And then this x value for the next one is b. I'm looking for the y value for that. Method doesn't change, guys. It is still the same. And then now we look at the substitution. When you substitute the value of x now to find the y value, doesn't matter whether it's h at x, is f at x, is g at x, is t at x, but what is it representing? The value of y, simply the value of y. Right, we have our expression y is equal to the x squared minus 4, And then starting with the first x value, which is equal to minus 2, we now substitute a minus 2 for x so that we can find the value of y that is coordinating with that x value. So this will be minus 2 squared, which is 4, and then a 4 minus 4 is simply giving us what? A 0. That this minus 2 now is now coordinating with the 0 there. And then the next coordinate, we are having the value of x as being b. Sorry, grade 12s, don't stress about having a variable. The method is the same in mathematics. Just keep in mind the application and the method to solve the problem. So we know that we are looking at the y values for both our coordinates. Let's check now if we substitute this b for x. What will be the y coordinate for that? Same method. We are taking the expression, which is the equation y is equal to x squared minus 4. And then the x in this case, we are substituting our b there. That will be b squared minus 4. That means this b is coordinating with the y value b squared minus 4. Don't stress, grade 12. Same method. I know that the minute we see variables, we start panicking. There's no need for that. Okay? We now look at our average gradient. Same method, we said we are going to say y2 minus y1 over x2 minus x1. It's now a national anthem, all right? It's x1, y1, and then it's x2, y2. Same application, nothing has changed, right? And then now, what is the y2? B squared minus 4, all right? Minus the y1, which is 0, over y2, x2, sorry, x2 is b, and then minus from our equation, and then the value of x1 is negative 2. So the minute we have negative by negative, it will change this to positive 2, grade 12. Okay, and remember now, this average gradient is given to us as being equals to what? Equals to 2. This is the average gradient, all right? So we are going to equalize this to 1 that is given to us. Okay, when you look at this now, you end up not knowing what to do. Let's simplify the numerators now, and we'll have an idea of what is happening. So we are having a b squared minus 4 on top, and then because it was minus 0 there. And then denominator you have b plus 2, which is still equal to 1 gradient of that function. And then now, look at that. Numerators, you are having difference of what? The two squares. So factorize using difference of two squares. That is b minus 2 and the b plus 2. Denominator, b plus 2. Grade 12? Can you see how important is your factorization? It is applicable throughout your mathematics. So you must ensure that algebra is your friend. Okay? And then there's a b plus 2 there. Cancelling again. Can you see we are repeating that something that we have done before? So throughout your maths, you'll be applying algebra. So we are left with b minus 2 the side. This is equals to 1. Therefore, b is equal to what? 1 transpose minus 2 plus 2, which is equals to 3. Therefore, we have what? Solved for the value of b. And then have you seen that the examiner have indicated value or values? They do not want to direct you whether it's going to be a single value or you are going to have two values of b there. So fortunate enough, we only have one condition of b, which is b equals to 3. Thank you. Moving on, it's now your activity, grade 12. We are going to have two of this. 1, 2, 3, 4 activities. Let's take another 10 minutes for that one. Over to you, grade 12. 10 minutes, strictly so. For this one, let's take 3 minutes for this one. Because they are not on the same slide, then we'll take 3 minutes for this and then move on to the next one after that. Okay, grade 12, your time is up. Let's go back to the activity now and see how far did you go with that one. All right, we are determining the average gradient. Since we are busy with that, we are giving the f at x equation, there you are, and then we are giving the x value equal to 1 and the x equal to 3. All right, and then now let's see, we have 1. We need the y value for that. We have 3. We need the y value for that. Same method. Remember, f at x simply stands for y. So we are calculating y values now for those x values. And then that will be 3 into 1 squared minus 7 into 1 plus 2. And then basically that will be 3 minus 7 plus 2, which is how much? A minus 2. Okay. And then this minus 2 coordinate with the 1. That will be 1 and minus 2. Let's look at the second y value now. If x is equal to 3 now, so that will be y is equal to 3 into the x value, 3 squared. Remember that square is critical. Sometimes you forgot to put a square in it. Always refer back to your equation, please. And then minus 7 into 3 plus a 2. And then this will basically give us the y value, which is equal to 8 in this case. So that 3 will coordinate with what? With the 8. So that is your x1, y1, technical mathematicians, x2, y2. We can go average gradient is equals to what? The y2 minus y1 over x2 minus x1. Substitute y2 8 minus, it's a minus from your expression and the minus from the coordinates. Negative, and by negative, positive. So that means y1 will be, the substitution will be 8 plus 2 now. And then the x2 is 3, and then minus 1 x1. And then this is giving us 10 over 2, which is equals to 5. Therefore, that is our average gradient for that one. Second activity. 3 minutes again, please, Atlanta. 3 minutes again, 3 minutes. Grade 12, 3 minutes. Okay, grade 12s, let's look at the solution now. And then if you look at this activity, we have tried that to change the question, the phrasing of a question. Remember, we are used to calculate the average gradient of a normal function that is a parabolic function. But in this case, look at this. It is now talking, contextualizing. Remember, we are technical mathematicians. Most of our questions will be based on real life situations. So this one is something that is mostly related to the real situation now. We are calculating the average speed between the point T, which is equal to 2 seconds, and T, which is equal to 5 seconds. If the relationship between the distance which is in meters and the time which is in seconds is given by the S into T equal to 3T squared minus 4T and minus 6. That means here is still the application of the average gradient because we are looking at the average speed. Can you see that, grade 12? And then remember, we are using to add 2 points where X is equal to an X. In this case, we just have changed that to T equal to 2 and the T equals to 5. Still, we are still given the starting point, which is our X value. So this T will be representing the X value then. The X is 2, and then our next value of X will be 5 there. Remember now, our T will be represented in terms of X, in terms of coordinates now. All right. I don't want to change anything. I don't want to change the language. I know you guys. I know you. We are all together in this. So we must simplify everything up to your level. All right. If the relationship between the distance now in meters and time in seconds is given by that expression. So yours is to look for your function. Our function in this case is S at T. Remember, I've indicated to you, it can be H at what, G at what, the S at what, but what is it representing? Only the Y equal to, when we are relating to the X and Y values of a function. Okay, and then let's move on now. In this case now, we are going to calculate the Y values that are missing here. We are not changing anything. We are not complicating the language. We also still want to talk to X and Y, all right? And then now, let's continue now. Remember now, our X is representing the T in the function that we are having. So let's take our function. All right, I want the Y values, the same method, right? But my T is now represented by the X there, which is equal to 2. And then this will be squared minus 4. The T is 2 minus 6. And then I hope we all got the answer, which is how much, grade 12? This will be 412 minus 8, which is 4. 4 minus 6, which is a minus 2. So that means these two coordinate with what? With the negative 2 there. I hope that is clear. And then to find the next coordinating Y value with the 5, we are now substituting a 5. That will be 3 into 5, and this is squared minus 4 into 5 minus 6. And then this is basically 5 squared, which is 25, times 3, which is 75, minus 4. But remember, I don't want to scratch your heads looking for the values. You just put this into your calculator. Therefore, it will give us the value that is equal to 49 there. So we have those coordinates as being 2 and minus 2, and then the 5 and 49. Remember, this is our X and Y from the original. But according to this expression, this is our T for time and the distance. Remember distance, which is indicated by S there. This is T and S actually. So I didn't want to talk in terms of T's and S to try to confuse you. I just wanted to relate this to the previous one, that grade 12, the application is the same as applying what? The X and Y. With the same formula, average gradient, always use what you are familiar with. That is y2 minus y1 over x2 minus x1. Okay, what is our y2? This is one family, this one is the second family there. And then the y2 is 49, minus minus 2, minus minus, it's now forming a positive, and then that is 2. And then the x2, we have 5 there. That will be 5, and then minus a 2 there. Straight and forward, you can just put that into your calculator, straight to the answer. So we are expecting the gradient of this function to be what? A 17 grade 12. Okay, let's take the last activity on the average gradient, and then we move on to the next one. 3 minutes again. Okay, grade 12s, let's come back now. You know the application hasn't changed. We need what? X and Y values for 2 coordinates, and then we go the gradient equation, and then we solve for the average gradient. Same method, ne? All right. So we are determining the value of A. If the average gradient for this particular function at x equal to A and x equal to 4 is what? Equal to 9. That means our gradient for that tangent is equal to m. For the average gradient of that function is equal to 9. Sorry for that. The gradient of this particular function is equal to 9. The average gradient for this is equal to 9. There we go, grade 12. Let's start. The method, remember we identify the x values that we have in the expression. So we are having the first x value being A, and then the second x value being 4. Same method, all right? And then now we need to identify step number 2, the values of y using what? The function given to you. Our function, we are given y is equal to the 2x squared minus x minus 3. We are now substituting the first x value. What is our x value? It's A in this case. Don't be stressed by the variables. Work with them. Familiarize yourself with that. Then will give us a y value that is 2a squared minus a minus 3. Back to the coordinates, it's a squared 2a squared minus a minus 3. That is our y value. Looking for the second y value now. And we take the same expression, y is equal to 2x squared minus x minus 3, same equation, grade 12. We now substitute the value of x, which is 4, that will be 2 into 4 squared minus x is 4 minus 3. And then this into our calculator, so we end up with the y value being what? 25. And then plug in, so this is coordinating 4 and 25. Happy now, we have our coordinates. First bracket is family of x1, y1. Second bracket x2, y2. Average gradient still the same. Equation, nothing has changed. Right. And then this is equals to the y2 minus y1 over x2 minus x1. But remember now, this average gradient is given to us as being how much? Equals to 9. So whatever we are doing here, we have substituted the equation of the average gradient, which is y2 minus y1 over x2 minus x1. This will still be equal to 9 because the average gradient of that function is equal to 9. So let's substitute now. The y2 is 25 minus the y1. Look at this. y1, you are having 3 values there. Okay? So if we have 3 terms there, therefore we need a bracket grade 12. We cannot just say minus 2a squared because negative will only affect the 2a squared. Whereas it is minus the whole thing. All those terms must change. So it will affect all of them, all 3 of them. And then divide by x2, which is 4, and then minus the x1, which is 8. Remember, this is still equals to a 9. Okay? Then you are having 25 minus 2a squared plus a plus 3. And then everything over 4 minus a equals to a 9. Happy creatures? And then from here now, we can check the like terms on the numerators. So we are having, let's rearrange this in order now. We are having 2a squared minus 2a squared. So continuing on this side, grade 12, minus 2a squared plus a. And then we have a 25 plus 3, which is plus 28, correct? And then over 4 minus a. And then this is equal to, remember what? A 9. Okay? And then now we can multiply with the negative on top there so that we can be able to, or take out the negative, that will be 2a squared. We want to factorize this, so we must get rid of that negative. And then that is 2a squared minus a minus 28. Also on the denominator, we can take out the negative there. So a will now change to positive, and then 4 to negative 4 equals to a 9. Okay, and then in this case now, we can cancel negative and negative, factorize the numerators, and then we have a minus 4 equals to 9. And then now, factors of 28, you subtract, get a minus 1, affected by that 2. That means this 2a squared will give us a factor 2a by a. And then the 28 will give us a plus 7 and a minus 4 this side. So a minus 4, a minus 4. So we are having 2a plus 7 is equals to 9. And therefore, the 2a is equal to 9 minus 7, which is how much? 2. Then we end up with the a equals to 1. Grade 12. And then now, there is some restriction missing there, but I'm not going to address this now, all right? Okay, even the space is not allowing me to look at that one. Let's save that for next time, all right? Okay, and then now, grade 12, let's move on to the next subtopic. We are looking at the first principle now. That is our last subtopic for today. So first principle, one problem will be in your papers, in all the mathematics, technical maths papers that you'll be writing. There will be a first principle question which is worth 5 marks. So please familiarize yourself with this one and ensure that you master this. All right. And then let's see now. When you talk to first principle, we are talking this formula, and then you will find the formula on your formula sheet. Please, grade 12, ensure that you have copied the formula correct. What is critical, most of the learners, they always forget to put that dash on top there, which is indicating the derivative to us. First principle is the f derivative of x, which is equal to the lim of h approaching 0. Can you see that lim is now coming back? So we are going to apply the same method that we were doing with limits at the beginning. And then this is f at x plus h minus f at x over h. All right. Now let's look at the worked out example. We are differentiating the following using the first principle. But if you look at our f at x, we have f at x equal to 7. And then when you look at the expression there, or the equation, it needs an f at x plus h, and then the f at x, so that you can solve using the first principle. Happy grade 12, we do have an f at x, which is equal to 7, but we still have to look at what? The f at x plus h. And then if we say x plus h, what happened now? Into that x, initial f at x, the x there, it is now substituted with x plus h. That means in our expression now, wherever we are having an x, we need to change that to what? X plus h in this case. Unfortunately, this 7 is not having an x, so we cannot apply any x plus h into 7. So our f at x will basically be the same as what? The f at x plus h. Happy now? Now we can now take our formula, because we have now f at x, we have our f at x plus h. So our equation is the derivative of x is equal to the limit of h approaching 0, which is our f at x plus h minus the f at x, everything over h. Look at the notation, grade 12. The equation equal sign must come before the lim, not after a lim. Please double check with the formula sheet to avoid mistakes. And then I'm continuing with the lim of h approaching 0. Why? Because I'm now going to substitute the f at x plus h and the f at x. What is my f at x? Plus h is equal to 7 in this case, minus my f at x is equal to 7. Look at that. And then everything over h. All right. Simplifying that, I'm having the limit of h approaching 0. Because I am busy simplifying, I have not substituted the h value yet. So that will be 7 minus 7, which is equal to 0 over h. I am still simplifying grade 12. You simplify up to the latter where you can't simplify anymore. It's only then that you now look at the h approaching 0. So we are busy simplifying. It's a 0 divided by h, which will still give us a 0. 0 divided by any number, it's 0. Okay. The only case that is undefined is when you have h over 0. Therefore, this one is undefined. All right. And then now, the limit of h is approaching 0. Do we have h there? No. Therefore, we just have an answer equal to 0. You still remember? We have a limit of 2 with x approaching 3. Our answer is that constant value, which is 2. So we are applying the same application that we did when we were doing what? The limits at the beginning. Okay, grade 12, I hope we are still together. Let's look at the second example now. We are given the f at x equal to minus 6x. We are still applying what? The first principle to differentiate the following. We said before we go with the formula, we check what? The f at x plus h. All right. That means where we are having an x now, we are substituting with x plus h. Look at that. Where I am having x now, I am substituting what? An x plus h. We can't leave it like that because we are simplifying brackets. Therefore, it will be minus 6 times x, which is minus 6x. Minus 6 times h, which is minus 6h. Therefore, this is our what? Our f at x plus h for this particular function. Now we can now move on to the derivative first principle formula, which is f. Please don't just note it down, double check in your formula sheet, is it copied correct, okay? That is f at x plus h minus f at x, everything over h. So we are having the limit of h approaching 0. Step number 2, we are now substituting, right? What is f at x plus h? That is minus 6x minus 6h. Minus. This minus is from the equation itself. But if you look at your f at x, it is now bringing another negative. We said the minute we have two negatives, they are now changing to what? Positive. We've been doing this grade 12. Therefore, this will be 6x, everything over h. Look at that. 6x minus 6x. At that stage, no matter what, there must be some cancellation. And your f at x original must disappear. The minute it also shows there, you must know you are going wrong. All right. Right, we are left with the limit of h approaching 0 of minus 6h. This is now over h. Simplify, h will cancel an h. We are left with the limit of h approaching 0. We are left with minus 6. Can you see now we are left with a constant again? There's no way that we can say h is approaching 0 because we don't have any h in our expression. Whatever is the constant, it will be our answer, which is minus 6. Let me show you something, grade 12. In relation to your answers, look at this. Our answer is minus 6. Can you see that was initially the coefficient of your x? All our first principle equation for technical mathematics. Lucky enough, the answer is already there in our given expression. All right, let's look at the second one. Whether am I telling the truth? Okay, let's see now. We are having f at x, which is 1 minus 3x. And then the method is look at f at x plus h before you go to the equation. So where I am having an x, I'm going to change you. So that will be what? A 1 minus a 3. But for x, I am now changing this to x plus h because I'm looking at f at x plus h. There you are. Continue. We have bracket. We can't leave this with brackets. We need to simplify those brackets. Let's see now. We have 1 minus 3x minus 3h. Correct. Therefore, this is our f at x plus h for that particular expression. Okay. Now we have the f at x plus h. And then let's look at the equation now. F derivative of x is the limit of h approaching 0. Remember the formula. I will sing this until it's set in your mind correctly so. Okay. Minus the f at x. Please remember to check the formula sheet. And then this is the limit of h approaching 0. What is our f at x plus h? That is 1 minus 3x minus 3h minus the f at x. We have a challenge now. Our f at x is having two terms. Remember, initially we were having only one term. It was easier for us to just substitute, change the sign, and so forth. But the minute you have two terms, remember when we were having a 2a squared minus a minus 3 with a negative, it is affecting everything. Same application. So we need a bracket there because we are having two terms. Clear, grade 12s? And then everything over h. Why? Because this negative is going to have an impact on both terms. Okay, not only one, both of them. All right, continue. Limit of h approaching 0. We have 1 minus 3x minus 3h. We now deal with the bracket. That will be minus 1 plus the 3x. everything over h. Let's see now. We said after simplifying, there must be some cancellation. It's a 3x minus 1 and 1. Can you see now? I can't trace that f at x original that was given to me. Therefore, I am going into the correct direction. After cancelling, I must not see that f at x again. I hope we are together, grade 12. Let's see what is left now. We are left with the limit of h approaching 0 of minus 3h over h. The h will cancel in h. Look at that. Limit of h approaching 0 of minus 3. Can you see? I am left with a constant again. I don't have to stress about h approaching 0 because there is nowhere where I am substituting that. That's a bonus for you, technical mathematicians. With mathematics, you can't see this. It's a bonus for you learners. Please, let's grab this with our both hands because it's a given to us. All right. Look at the answer now, related to the part that is having an x. Can you see the answer is the coefficient of x? Your answer will always be a coefficient of your x for technical mathematicians because you are only solving what? X to the power 1 in all your expression, or is either a straight constant without an x. I hope we are still together. And then let's look at this one. Okay, the difference there is now that we are having a pi. Remember, a pi now is distracting us in most cases. In almost most of our technical mathematics topics, you'll be seeing this pi. It is in trigonometry, you'll be seeing this pi. By a pi, remember it's a number, grade 12. It's a constant value. It's like having a 1, 2, 3, 4, 5. It's a constant number because it has a value which is 22 over 7, approximation of the number, and then which is approximately 3,14 if we round it to the second decimal. So the minute you see a pi, you must know we are talking to a number. Do not confuse with radians, ne? We are not in trigonometry. I know sometimes when you see a pi, you only think of radians. But in this case, we are talking an actual pi, which is 22 over 7, or a 3,14, which is a constant number. Right. Let's continue now. Method is the same. We have f at x. We now look at f at x plus h. Right. We have that pi. We have minus a half. Where I am having an x, I am substituting a x plus h. Let's continue now. We have a bracket. Get rid of that bracket. Minus half x minus half h. I can't take a bracket into my expression. I want to make my life easier and avoid confusion, right? So when I'm done with that now separately, I now move to my expression. F derivative of x, which is the limit of h approaching 0, of f at x plus h. That's my formula from the formula sheet, and then divide by h. The lim of h approaching 0. My f at x is pi minus half x minus half h. Minus, I'm having two terms now. I need that important bracket, right? That bracket is a lifesaver. It must be there. That is why I am putting an effort on that one. I am emphasizing this, okay? So that will be pi minus half x, because I'm having two terms. They must be inside the bracket. Everything over h. The limit of h approaching 0. Then I'm having pi minus half x minus half h. Then negative into the bracket minus a pi plus 1 over 2x, everything over h. Oh, you said something about cancellation after simplifying. Okay, half x minus half x minus pi plus pi. We cancel only if it is opposite sign, because pi minus a pi is 0. Half x minus half x is 0. That is why we are cancelling that, because they are giving us zeros. They are not just disappearing, eh? They are giving us a 0 when we subtract. So look at that. We are left with only the limit of h approaching 0 minus half h over h. The h will cancel the h. Limit of h approaching 0. Left with minus half. Constant value, the answer is minus half. Grade 12, I want to emphasize something now. Look at the limb. I'm having a limb throughout. There is no way this limb can disappear, okay? It must appear in all your steps up to this far. Only on your answer is where you are not going to have that limb anymore. Your answer must not have a limb, grade 12. Let's compare. The coordinate of x is minus half. Is my answer minus half? Yes, it is minus a half. Therefore, I'm 100% correct. Okay, let's take 3 minutes now looking at the activity for you guys. Okay, let's take number 4. 3 minutes. All right, graders, I hope everybody got the correct answer. You know the expected answer, isn't it? We are expecting our answer to be the coordinate of x, so we are expecting you to get what? A 1 over 3 as an answer. Let's see. Remember, the method doesn't change. You must start by looking at x plus h. Before you confuse yourself, go into the formula, right? So we are having a 1/3. So for x, we are substituting an x plus h. Wherever we see an x, we put in an x plus h. There we are. Bracket, we can't go with bracket. It will cause a confusion for us. We simplify them there before we take them into our formula. So it's 1 over 3x plus a 1 over 3h plus a 6. There you are. You have your f at x plus h, grade 12. And then now we can now substitute into our formula. F derivative of x is equal to the limit of h approaching 0, f at x plus h minus f at x, everything over h. And then the limit of h approaching 0, f at x plus h is 1/3 x plus 1/3 h plus 6. Minus, I have 2 terms. Remember that bracket? It's 1 over 3x plus 6 there. And then everything over h. That's the limit of h approaching 0. 1/3 x plus 1/3 h plus 6. A negative into the bracket minus 1 over 3x minus 6. Everything over h. Do not forget that h grade 12. And then now the minus 6 plus 6 minus 3 plus, sorry for that, we are left with the limit of h approaching 0, 1 over 3h over h. H will cancel in h. Can you see we are left with the constant 1 over 3? Then our answer will just be 1 over 3. Okay, grade 12s, thank you very much for your time and everything. Thank you for listening to this. This is the end of our session. And then the next session will be on the 9th of March 2022. And then the focus topics will be differentiating using the rules and equation of a tangent to the curve. I thank you very much, grade 12. See you then, all of you. I hope this was a very informative lesson for you, which is brought to you by Department of Education in collaboration with Cybono and broadcasted by Pakama Research and Development.